In section 1.5, you're going to be talking about transformations, and these are all applicable to the parent graphs that you have already had to memorize. I'm going to request that you pause the video and write all this down and then come back, and I'm going to talk through some of it. We're going to do lots of examples of this. All right, so this first set up here is talking about being outside the function. All right, so the function itself could be the square root of x, it could be 1 over x, it could be x cubed, x squared, it could be the absolute value of x. So all of these set of changes are vertical transformations. So these will change the y values. Each one of them does something different to the y values, so you got to pay attention to that. The bottom set are inside the function. So, for example, if you had the absolute value of x plus 7, that would be the top one of these, and that makes it go left 7 units. So these are horizontal changes. So these will change your x values. So paying attention to whether the x's are changing or the y's are changing is something that you're going to have to do throughout this section. So we're going to go through and do some examples. If there's anything on this page that confuses you, we can discuss it in class next time I see you all. And if all of this makes sense and there's something on the examples, all you have to do is let me know. Okay, so here are a few examples of what we're going to be looking at, and this is saying what is the effect on the values. So for each one of these, you have to understand that the parent graph started out being f of x is equal to x cubed. So what I always encourage kids to understand is, am I inside or outside? All right, so this plus 4 is on the outside. So that means that it is a vertical change, and it will affect the y values. So these y values will be impacted because you will add 4 to each one of the y values. All right, and then the effect on the graph, because I'm adding 4 to every single y value that it has, it means it goes up 4 units. So on the next one, we are inside because we are going to add 7 before we take and cube the number that we have. So this is an inside change. So this will affect your x values, and each one of those x values will have a 7 added to it. And on the graph, what this is going to do is move this graph left 7 units from its parent location. All right, this one, very much like the very first one, this is an outside. So this is going to affect your y values. So this is a vertical change. And this will add 3 to each one of your y values. So this is going to move it up 3 units. And again, the next one, very much like the second one up there, you've got a 3 on the inside. So your x values are impacted because they are going to have 3 added to them. Each one of the x values will increase by 3 before you cube it. So this is going to make it move left 3 units. Another question type you might see is that they want you to come up with an equation. So in this one, you're having a parent graph of y equals x squared, and it tells you to move up 2 units. So this is a vertical change, and that means that we are going to have an outside adjustment, vertical and outside. So if my parent graph is x squared, and I go up 2, then I add 2. So that would be my new equation. All right, so I have a shift of up 1, right 3. So up 1 is outside, right 3 is inside. So then I want to have the new equation will have an inside right 3, so you subtract and square it. And then if I want to go up 1, then I would add 1 to it. And the last one, I have a parent graph of 4 square root of x. Now, this is not a parent graph. This is a new function that they're having you start with. But if you want to go down 2, that's an outside change. And if you want to go right 4, that is an inside change. So inside would, of course, be under the radical. So the 4 is still there. Inside, we're going to go right 4, so that means we're going to subtract 4. And if I want to go down 2, that's an outside change, and we will subtract 2. In this question, they're asking you, with respect to the original function f of x, how do we create the g of x function? So if you look at the g of x table, the y values have stayed the same, and the x values are decreasing by 1. So in order to write that, you would take f, and you would subtract 1 from every x, and that would be your equation. Now, for h of x, the x values are staying the same, and your y values are changing. So to go from -2 to -1, also to go from 2 to 3, you are increasing your y values by 1. So we write this as f of x, and then I add 1 to every y value. We're looking at the graph of this, and what we are trying to find out is where does it move and how does it get there. So if my parent function is f of x is equal to the absolute value of x, then that ordered pair point in its parent form would go here, here, and here. So what we need to find out is how does it get to here, here, and here. So for any one of those 3 points, we would be going down 3. So down 3 first. And then I would go right 2. And that same pattern follows all the way through. So to come up with the new graph, we have f of x is equal to absolute value of x minus 2, and then we will subtract 3 to go down. So that would be b in this case. The next couple of questions are doing the same thing, but they don't give you a multiple choice answer. So in this case, I know that my parent graph is f of x is equal to the absolute value of x. So again, in its parent form, it starts here. So what we need to find out is how do I get it to go up to there. So in this case, I would go right 1 and I would go up 2. So right 1 and then up 2. And to make that happen, we will have f of x is equal to absolute value of x minus 1, and then up 2 is adding 2. Now, the next thing I have to check is to make sure that this point does the same pattern. So if I go right 1, up 2, I'm there, which is where I should be. And then you can check it with that third point if you choose to do so. Next question, we are asked the same thing. So in this case, we have a parent graph of f of x is equal to the square root of x. Now, in its parent form, I'll do it in red. It goes here, here, and here. So that would be in its parent form. So all we've done is reflect across the x-axis. And in order to do that, you have to have a negative sign on the outside of the graph. So negative, and then you have the square root of x. Next one, again, we have our parent graph is still the absolute value of x, so it would go here, here, and here. So when we look at where it has gone now, it's been reflected across the y-axis. So in order to come up with this blue graph, I would have the square root of negative x. The negative goes on the inside. Okay, the next one, we have a parent graph is given, and it is k on our online. So to get to g, we have reflected across the y-axis reflection. So that would be a negative on the inside. So that would be this one. Okay. All right, so then b would be a reflection both across the x and the y, so that would be this one. And then when I look at a, that has to be r. So if I'm looking at the original parent graph k, and I reflect that over the x-axis, that will be this one. We're going to work a little bit more with exponential graphs. That's what this one is. So you have a base of 7 and an exponent of x. The outside of this would be anything that is external to 7 to the x. Think of that as an entire unit of the parent function, and then inside would be up there in the x where the variable is. So it's like in the exponent location. So if we're going to go down 8 units, then 7 to the x stays, and then I'm going to go down 8, so I subtract 8 on the outside. If I'm going to go left 8 units, then that has to be an inside change, and because I'm going left, this works the opposite of the way we would want it to, so that is going to be 7, and within the exponent location, we will be adding 8. And then in the last one, I have a reflection over the x-axis and the y-axis. So I have a negative out front, and I also have a negative on the interior. So with exponentials, you have to be careful about inside and outside. Next one it's telling you that it's a graph of the quadratic, and it wants you to find the equation of this graph. So the first thing I'm going to do is know that in its original form, it starts here, it starts here, here, and here. So the very first thing I'm seeing is that it doesn't even open up, okay? So it opens down, so it's going to reflect across the x-axis, reflect over the x-axis. So at that point, I know that I have f of x is equal to negative x squared, okay? So I'm going to erase those points because now they go this way. So then I need to figure out how am I going to get up to where my vertex point is up to here. So to get there, I would go right 1 and up 2. So right 1, up 2. So that means I'm going to take what I have in red already. So I have negative x squared. Now, if I'm going to go right 1, that is an inside change. So I have to slide this x squared over. So if I'm moving right 1, I subtract 1. And then in order to go up 2 units, I have to add 2 to that. So then I can check with these other ordered pair points. So if I start here, if I go right 1 and up 2, I end up where I'm supposed to be. And if I take this other one, right 1 up 2, I end up where I'm supposed to be. So this is my final answer, and that's what I would type in online. All right, the next one doesn't tell us what the parent graph is. It just tells you that it wants to make these changes. So I'm going to do these one at a time. So if I have a vertical stretch of 8, that is going to be impacting the number a. So this will be g of x so I'm going to have a vertical stretch by 8, so that stays there. So then I have x, and then I've got these other changes. So moving on to the second change. If I go right 6 units, well, if I go right, this is an inside change, and the inside change is going to make it so that I do a subtraction of 6. So b would be the number negative 6. And last but not least, we're going to have an up 5 units. So that is going to impact c, so that we will, on the very end, be adding 5. All right, these next 2 questions give children some problems sometimes. This is my parent graph that has ordered pair points at these 3 locations. Now, when I look at the one below it, that's going to be a new function that's based on that parent graph. So you can think of the top one as being the parent graph. So as I look at this, are any of those points in the exact same place? Well, the only one I see that's in the exact same place is 1, 0. All right, then I have some changes. So to get from the top graph to this bottom point here, then up at the top, I have started at the ordered pair point 2, negative 2. And here I have 2, negative 4. All right, then I do this with the last ordered pair point here. So at the top, I have the ordered pair point 3, negative 1. And on the bottom, I have the ordered pair point 3, negative 2. All right, so this ordered pair point up here, I'll just 1, 0, and this is still at 1, 0. All right, so the red point on the bottom did not make any changes. The minimum point went from 2, negative 2 to 2, negative 4. So that looks like I have a vertical stretch by a factor of 2. All right, so then I'm looking at the last one. So a vertical stretch is going to change my y values. So my y value up here is negative 1, and down here, did I multiply by 2? I did. And I'm noticing that there are no other changes. Okay, so my y values have changed, so it's a vertical stretch by 2. In order to accomplish that, I would have a 2 out front. So this would be f of x is equal to 2 times f of x. There are no other changes, so that means that b is still 1 because there was no horizontal change to this problem. All right, so the next one is asking the same thing. I'm starting with a different parent graph. So my parent graph this time starts with negative 1, negative 1. I have 0, 1, and I have the ordered pair point 2, negative 2. So as I look down at this bottom one, I'm looking and I'm saying, okay, I've got that point is 0, 1, so that's exactly the same. But this point is not the same, okay? This point is pulling me over to where I'm going to negative 6, negative 2, okay? So both my x and my y have changed, all right? And this one is not at 2, negative 2. This one is at 3, negative 1. Now, if you didn't notice in the original, and I'm going to highlight it in green, this is my shorter segment, okay? And in this bottom one, this is my shorter segment. So I had a lot going on right here, okay? Number one, it has had a reflection across the y-axis. You have to notice that first. If there are any reflections, you have to take care of those first. So if I have a reflection across the y-axis, that means that b is going to be a negative number. So if I have g of x is equal to, now I'm going to have something with a, I'm going to have an f, and then I know that that has to be a negative b value, okay? So I got to figure out what the rest of this is. So if I reflect this top graph, and I reflect this over the y-axis, then 0, 1 stays where it is. I'm going to go negative 2, negative 2 would be down here. So this point right here is now this point right here. And then on this side, I would be at 1, negative 1. So this point right here goes to here. So the one in red is my parent graph. This takes care of the reflection across the y-axis. So now, since I've taken care of that and I have this negative in here, now I'm taking my black graph on this side and I'm trying to figure out, well, how does that change to get to my blue graph? So this is negative 2, negative 2. This is still 0, 1. And now this is at 1, negative 1. So if I look at what happens from here, my x values are changing. So this x value right here changes into this x value right here. So this is a horizontal stretch by a factor of 3. So in order to do a horizontal stretch by a factor of 3, remember these work and you have to talk about the reciprocal of this. So a number of 1/3 up here means that I have a horizontal stretch by 3. And then, of course, the negative is because you have a reflection over the y-axis. So this would mean that you have A is 1, and B would be the number, A is 1, and B would be the number negative 1/3. The next graph is giving us a quadratic, so we know that we're starting out with f of x is equal to x squared. So the first thing I see is that it's inverted over the x-axis, so that means that I have a negative that goes out front. And then I notice that it goes down 2 and it went left 1. So I have x plus 1 quantity squared, and then I'm going down 2. Now with these equations, you have to make sure that there's not been a vertical or horizontal stretch. So I'm going to do negative a, x plus 1 quantity squared minus 2. And we choose an ordered pair point that is not the vertex. So I'm going to choose this point right here. I have 1, negative 3, and I'm going to plug that in and solve for a. So I have negative a, 1 plus 1 squared minus 2. So I'm just substituting that ordered pair point into the equation I have so far. So I'm going to have negative 3 is equal to negative a. 1 plus 1 is 2. 2 squared is 4 minus 2. So I'm going to add 2 to the other side. That leaves me with a negative 1 is equal to negative 4a. So a is equal to 1/4. So I plug that answer in to this equation, and that will be my final answer. Now, you can always check these. So I have negative 1/4, x plus 1 quantity squared, and then you're going to subtract 2. Now, the way to check it, and I'm not going to do it on here, but the way to check it is to choose another ordered pair point and substitute it in, and it has to make a true statement. We will be doing the exact same process in this next one, but my parent graph this time, of course, is f of x is equal to the absolute value of x. Again, the first thing I'm noticing is that it's inverted. Okay, it has reflected across the x-axis, so I have a negative here. It also moved right 1, and then it went up 2. So again, I have, this is my initial scenario. So what you're always going to want to check with these is to see what, if any, vertical stretch it may have. So I'm going to choose an ordered pair point that is not that maximum point. So I'm going to choose this one. I have the ordered pair point 5, 1 that I'm going to plug in. So I have 1 is equal to negative 5, absolute value, negative a, absolute value of 5 minus 1, plus 2. Be very careful to use your order of operations. So you have the absolute value of 4, and then add 2. So this is 1 is equal to negative 4a, because the absolute value of 4 is 4. And then I'm going to subtract 2, so I get negative 1, and we get an a value of 1/4. No, they will not always be 1/4, but these two just worked out, and I randomly chose these. So my final answer for this question will be f of x is equal to negative 1/4, absolute value, x minus 1, and then plus 2 on the outside. Again, you can choose another ordered pair point, plug it in, and see if it works. I'm not going to do that on here, but that is a way to double check yourself. See me with questions.